Hey, welcome back to a new day. In this short video, I want to give you an overview of what you did yesterday. Yesterday was about creating your own functions. We built this custom function here. This custom function read the todos.txt file and it returned the to-dos in that text file as a list. And then we call this function at several places in the script, such as here. So we get the list of to-dos and store it in the to-dos variable. And then we do further operations to that to-dos list. We also called it here in the show condition and also at other places in here. So the main benefit of having a custom function was that we can simply write the code once here and then we can keep the code cleaner by just calling that function. Now today you're going to learn more about custom functions. You're going to learn how to write more advanced functions. So let's get ready and I'll see you in the next videos. Thanks. Previously you learned how to create your own functions. And to explain functions, I made a parallelism with the barista example when you go to order a coffee and you tell to the barista that you want the coffee. Now, I don't know if you thought about this, but when you say you want a coffee, the word coffee is the input you give to the coffee making process. So the barista gets your input and then returns the cup of coffee to you. So we didn't mention this previously, and we also didn't have any input for this getToDos function. But in this lecture we're going to enter some input for this function. So there are functions which don't get any input, and there are functions who get an input, or argument in other words. So for example, the input function gets this argument. The print function also gets this argument. So how can we change this function definition so that the getToDos function also gets an argument when it is called in here? So that's what we're going to do now. But let's think, what input could this function get? So this function gives us the to-dos. And for the function to be able to give us the to-dos, the function needs to know where the file path is. Now in this case we have hard-coded here this file path. With hard-coded I mean we didn't provide a variable, but we wrote the actual value, a string in this case, in the function definition. It would be better to change that into a variable such as file path and then have file path as an argument. So that's how you create arguments for function definitions. And then you provide the value of that argument in here, which would be todos.txt. So if I run the script now, things will work the same. And what will happen is this. I'll execute the script and the interpreter will read the recipe and then it will check the command, it will execute this, and then it will execute this line here. So that will call the function, this function. And that's when all these lines will be executed. So when the interpreter reads the function, it just reads the syntax, it doesn't execute the lines. But then when you call the function in here, then the interpreter goes back to the function definition and it executes this line. So in this case, file path will be replaced with this value. So basically this is a variable, a local variable inside this function. So inside this function, this is the equivalent of saying now file path is equal to todos.txt. That's what's happening here, although implicitly. So let me remove that. So file path will be equal to todos.txt. Whatever we give here, that is used here. Therefore, the function will open the file, the todos.txt file, will read it as it normally does. It creates the list and it returns the list, and we capture that list in the todos variable here. That's the idea. Likewise, if we used our example here, where we greet the user, this function also doesn't have any input, any arguments now, but if we place here message and we remove the variable declaration in here so that it is not hard-coded anymore, we let the user now enter wherever they like for message. So they don't want to say hello, they want to say hi, and then we print the length of the greeting, or we print the greeting itself. So let me print the greeting itself and to run test, and we get hey hey by that, and hi because we passed hi there, and the function is printing that new message with the first letter capitalized. So even if it's lowercase, we again get hi with uppercase H because we capitalized the letter there. Now you could ask, well, again you hard-coded the value here. Yes, but you could easily get that from the user. So user entry, and you say input, what greeting do you want? You could ask the user for that and then place here user entry, run the code. What greeting do you want? The user wants good afternoon. Press enter and they get good afternoon. So this is a very simple function, of course. It just prints out the message. But it's just to illustrate how functions work, so they are there as a recipe. Back to our main app. So as we said, when this is called, todos goes there, and we want to do the same for the other calls. So we have a second call in here that will also use the same file path, todos.txt. We have a third one in here under edit, todos.txt, and a fourth one under complete, todos.txt. And if I run the script now, and I try the show command, so which will execute this code here. So let's try show, and we get the existing to-do items in the list. So the getToDo function is working well. And that's how you create functions with arguments. One last thing before I close the video is that the terminology, actually, when you define the function, this is known as the parameter of the function. But when you call the function, this is known as the argument value. And the argument itself is this. So this is optional. You can mention the argument in here and then assign it the value, but you don't have to do this. So that will also work, but that is also fine. So that is a parameter in the function definition, the argument here, and the value of the argument. Now you have to decide whether you want to mention arguments or not, and there's no specific recommendation for that. So sometimes it makes for a shorter code not to mention the arguments, but just to leave the value there. Other times this could give some more context to the programmer who is reading the code, so you know that This is actually a file path. So that is also fine. It is recommended not to leave spaces around the assignment operator here. So this is not necessary, and it is not recommended because it's too much space. So it would occupy too much space, so this is fine. Unlike the variable declarations where it is recommended to have spaces. So leave it or remove it, whatever you prefer. I'll prefer to keep the code cleaner, so I'll just remove that. It is quite obvious that this is a file path. So I think it is not necessary in this case. Thanks a lot. See you later. Hey, welcome back. We have been using this example with the client and the barista, where the client orders a coffee to the barista and the barista prepares the coffee. So when the client says coffee, that is the input, and the process of coffee making is the function. But sometimes the client could say more than coffee. They could also say milk or sugar. So what they're doing is they are providing multiple arguments, multiple inputs. And the function, the process, will consider all these arguments during the process, so that the product is a result of all these arguments, the interaction between these arguments. So the same works with Python. This function here gets only one argument, file path. But it could happen that the function needs more than one argument. However, this particular function doesn't really need more than one argument. So the only changing factor here could be the file path. That's why this has to come from the outside. Therefore, we will not add multiple arguments to this function, but we have something else here. We still have some repetitive code when we write the file. So we have one here in edit. We have these lines, the same ones, under add. And what else do we have? We also have a third instance of those two lines under complete. So what I'll do now first is I'll create another function. So define, let's name this write to do's. So that's what this function will do for us. This function gives us the to-dos, this function writes the to-dos in the file. And here we're going to place these two lines. And now let's think, what does this function want to know from us, from the entity that calls it? So the entity is, we could say the entity here is this add case, the add condition, and in this block of code, this calls that function. So what kind of information should we send from this place to the function? You could also say that this if conditional block is the client that uses the function. So there are different parts in the program, different entities, right? So think of the program as the cafe, and the client is here who uses that function, and the function is the process, the making of coffee and so on. So the program is the cafe where everything happens. So for this function to be able to write to-dos in the text file, it needs to know two things. It needs to know the file path, and it needs to know what to write in that file. In this case is the to-dos. So these are local variables. Therefore, it's a good idea to have different names from these. So that and that is not the same variable, as I explained previously. That is a global variable, that is a local variable. So to be more clear, let's say to-dos arg for argument. So that will be the argument. And then you replace the literal string with file path and to-dos with to-dos underscore arg. And then replace these two lines with write to-dos.txt and comma to-dos. I didn't assign it to a variable, I'll explain you why exactly. And also we didn't return anything in here. Why? Well, because this function is more like a procedure. It doesn't return anything. So it modifies some components. In this case, it modifies the file, the text file, but it doesn't need to return anything. We don't need any value from this function. This function just has to go somewhere, do that, and that's it. So that was different from this function, which returns something. And we captured that return in the variable here, to-dos, equal to get to-dos. And with this function, write to-dos, since it doesn't return anything, we have nothing to capture. And as I mentioned, this function actually returns a non-object, which is useless. So if you did here variable equal to that, variable would be getting the non-value, which, as I said, is useless. So this function, the role of this function is to behave as a procedure. So what happens is that, again, the interpreter will read the syntax of these lines, and if the syntax is okay, then it carries on for the other lines. So then it executes this line, executes that. It actually executes them because they are not in a function. And then it executes that, and this, and that, and that, and then goes here. So what will happen here is to-dos, this value will go as the value of the file path local variable. This is an argument, but it's also a local variable in this function. And the same goes for this. So to-dos at this point, it holds a list. So to-dos is actually a list. So that list object will go as the value of this to-dos underscore arg local variable. So think of that list as a ball, a tennis ball, and you just throw it from one person to another. So you throw it from one variable to another. So at certain points, one person has it, at another point, another person has it. So that's the value of the ball. And then the ball is used in this procedure, in this function. So the ball then is written somewhere in the text file. So it's placed somewhere. And then we see that's in here somewhere. So if I run the script now, it should be working fine, but I would like to also replace these lines as well. So this is under edit. This would also be write to-dos.txt and to-dos. So that goes there. Same goes in here. Write to-dos.txt, to-dos, that variable. So The user enters a number for the to-do item they want to complete. We read the to-dos from the existing file using the getToDos function. So we grab that list in the to-dos variable. We remove the to-do from the list with pop. So the list is now updated, and then we send the list to the right to-dos function. And the function will get that list and it will write it in the todos.txt file. That's the idea. So now the code is more organized. We don't have repetitive code. If we want to change something regarding the file reading process or the file writing process, you just change that in here or there. You don't have to change it everywhere in the code. So let's try out the code now. I'll add clean the codes perhaps. Show. Yeah, clean the code is added as the last to-do item. Maybe complete number 2. To-do pizza was removed from the list. Show. And that's the updated list. And that's the complete code for today. I'd like to clarify the terminology a bit before I close the video. So this here and that are parameters, are known as parameters. So when you are writing them here in the function definition, we tend to refer to them as parameters. But then this here is the argument value, and the argument itself is this. So if you mention the argument in the function call, this is the argument, and that is the argument value, and that is a parameter. Now this is optional, you don't have to mention the argument name in here, so this will work exactly the same. If I run the code now, I can add by the painting and show. So by the painting is successfully added, and so this is working just fine. Now which version should you use, this or that? Well, it depends. So the purpose always is to make the code as clean as possible, as readable as possible. So sometimes it might be useful to say here what this value is. So that will make the code more readable. As a programmer, you read the code, you see, oh yeah, this is a file path. So you understand immediately what kind of value this is. But in certain cases, like here, I don't think this is necessary, because we know that by just looking at this, we know that this is a file path. We see the extension, and this does look like a file name, like a file path, so you don't have to mention that. Same here, if you wanted to mention the argument name, you would say file path is equal to that, and here it would be todos arg is equal to that. So file path is that parameter, so the parameter name here, the argument. So when we call the function, it is referred to as an argument. The argument and the argument value. And that's todos arg, which is mentioned in here. And the value of that is the list. Style-wise, it is recommended not to have spaces around the assignment operator. So this wouldn't be recommended. Therefore, just do without spaces. It is recommended to have spaces around the assignment operator when you do normal variable declarations. No matter if you're doing local variables like this one in here or global variables declarations. So there are spaces, white space, around the assignment operator, but not here. And in our case, I would prefer not to have the argument names, but just have the values there. I think this is clear enough and readable. So thanks a lot for following, and I'll talk to you later. In the video tutorials today you learned about function arguments. Now we're going to run a few experiments to give you a more in-depth understanding about functions and about arguments. So the first experiment. In the getToDo's function definition, I want to change this toDo's local to file path. And I want to ask you to try to guess what the output of the program is going to be after I press here add turn off the lights. So if I press enter now, try to guess what output are we going to get, or what error are we going to get, or where the error would occur. Okay, so I'm going to press enter now, and it's obviously an error happened at this line 21, which is in here. So this is a training more about to understand errors than it is about arguments. So let's try to understand this error and try to fix it. When we get an error in a certain line, that means the code from that line and up was correct. So the interpreter executed the lines above the error line and then it stopped at that error line. That means the function is correct, the other function is correct, all these lines are also fine up to line 20. So even line 20, in line 20 we got the output of the function correctly, we store that output in toDo's. The problem is that now when the interpreter tries to use the append method over the toDo's variable, it says that this variable does not have the appropriate type associated with that method. So that is an attribute error. An attribute error means the method does not exist for that object. Before it existed because before we returned a list, but now we return a string. File path is a string, right? We give this string to getToDo's, so that replaces file path, and we return todos.txt, and therefore todos.txt does not have an append method because it is a string. So that is the logic here. Therefore, I want to change it back to toDo's local and continue with the next experiment. For the next experiment, I want you to try to reassign file path to a new file name. Let's say todos1.txt, not todos. Again, try to guess what will the output be when I run the script. And again, I try to add turn off the lights and I press enter. What is going to happen when I press enter now? That's the add condition. So I'll press enter now. And again, we have an error. This time the error has two parts. It first occurred at this line. So that's why here it says most recent call last. That means first the error occurred here and then the most recent is the last one here. So in other words, the interpreter first found out that it could not execute line 20, which is in here. So it tried to store that output in the toDo's variable, but it could not because of another error in line 3. So line 3 is where that getToDo's function is stored. Line 3 says that file not found error, no such file or directory todos1.txt. So line 3 is this one in here. We tried to open todos1.txt in read mode, but you cannot do that over a file which does not exist. So read mode does not work for inexisting files. If it was right, the file would be created from scratch, even if that didn't exist. But that's not the case with read mode. So this also helps us to make the point that you can reassign a value to the argument. So an argument is just a variable. Basically, when you say file path here, and when you call the function in line 20, so when you say get todos.txt, at that point, an implicit variable declaration occurs. The variable declaration is file path is equal to todos.txt. So at that point of the execution of the program, a variable is created. That variable is a local variable of this function, and then that variable can get other values, just like variables do. Normally, you can create a variable x is equal to 1, and then you can reassign it to 3, etc. So the same goes here, that will reassign a new value to variable file path. So let me delete that, and those were the two experiments I wanted to try out today. I hope this helps. See you later. Hi, welcome to today's bonus example. Today we're going to be working on functions. We're going to create a function which will deepen the understanding about functions in Python, and also it will introduce you to the concept of decoupling. Decoupling is a programming ideology that you should really learn. It applies to Python, it applies to all other programming languages. Programming with decoupling in mind will give you Programming with decoupling in mind will make your programs better. So I'll explain you decoupling as we build the program so you'll understand what it actually is. Right, I've created a Python file, and here I have this input function which, if I run it, it asks the user to enter feet and inches. So in the USA they have the system that lengths can be expressed in something like 512, which means 5 feet 12 inches. Now we want to create a function to convert that user input to meters. Let's do it. So we get feet and inches. We expect that kind of output. So feet divided by a space from inches. So we expect two numbers divided by space. So our function is going to be convert. We want to convert feet, inches. So that value will go here. This will be a string. And so once we get that string, we want to extract the two numbers from it. So what we can do is we can do this. Let's say that feet inches is going to be 512, right? Then if you say feet inches dot split, you can use the split string method, and you say where do you want to split the string at, and we say split it at the space. So here, in that case, what we're going to get is a list. So the split method works on the string and it returns a list containing the parts of the string split at that character. Similarly, you could have something like hey dash me dash you, and you split it at the dash and you get 3 parts of the string, hey, me and you. Now we want to save that list in a variable. So what we do is we say parts is equal to that, so parts is going to be that list. So let's do that. Parts is equal to feet inches that split at the space. And then we could say feet is equal to parts with index 0, so that will give us that number only, which is actually a string, so we need to convert it into a proper data type. Float would be the proper data type here because these are continuous values, so it could also be theoretically a decimal number. So float is better to have instead of int. And inches is float parts 1. So that will give us the second item. And we convert it into a float. So now we have each of those numbers stored in these variables. Then we apply the formula to get meters out of that feet and inches. So let's create a variable meters, and that would be equal to feet times 0.3048. So 1 meter is actually equal to that number of feet. That's why we multiply by that, and also plus inches times 0.0254. And that should give us meters. Then we can return something like return an F string perhaps. You could say that feet, and inches. So feet is the label, the string, and feet here is the variable. So you'll see how that renders in the output is equal to meters the variable, meters the label, and then print convert and you provide feet inches there. Yeah, now I know why you were laughing. This should be split, not spit. So let me make some space here. And here, let's make one more space. And I'll run the script now. Enter feet and inches, 512. Press enter, and it says that 5.0 feet and 12.0 inches is equal to that number of meters. So 5.0 replaced that part, 12.0 replaced that part, and that replaced that part. So far so good. So we have a function which converts feet and inches to meters. Now, this function of course is part of a bigger program usually. For example, let's suppose that this program is part of a bigger program in the kids' Disneyland where you have the slides and everything, and so they want to know the height of the kids before the kids enter this playground in order to know if they can use the slides or not. So they ask the user to enter feet and inches, and then their other devices need meters, so they convert that to meters, and then they check if meters is less than 1. If that's the case, then they say, oh sorry, this kit cannot use the slide. So for that we would need a conditional to check the result of that. So what we do is, instead of printing the meters out, we would need to store it. So the result is equal to that. So that should give us the return of that. And then we can check if result is less than 1. We say print kit is too small. And else you say kit can use the slide. Right, but the problem is result is a string, right? You see, that is the result. It is not a number, and that brings us to the concept of decoupling. The output of a function should be decoupled from other components. So that means instead of returning a string here, you should return one value, not such a complex component, because the value that you return might be used from other components in your program, such as here. The value that this function returns is used by this if-else conditional block. Therefore, the better way to do this is to just return meters here. So return one single value if you can. And then here, result now will be equal to the actual value of meters, 1.8 or whatever it is. So then you are able to compare that number with 1. So if I run the script now, enter feet and inches, 312, kit can use the slide. So that's the result we want, use it or not. Now you might also want to print out a message as we did previously, so to say that amount of feet and inches is equal to that amount of meters. You want to print that out as we just did 5 minutes ago. And the problem is, as the function is now, we cannot do that because feet and inches are now inside the function. We cannot access them because they are local variables. We cannot access them outside the function, but there is a solution to that as well, and it is also related to decoupling, but we will cover that later. Today we were talking about decoupling the output. Tomorrow we will talk about decoupling functions, and we will talk about this particular solution here. So for today, that's what you need to keep in mind. When you create a function, don't complexify the output. So this function is a convert function. It should get the input value and it should return the output value. This is feet and inches, this is meters. The function should do that and do it well. So with that, I'll talk to you tomorrow. See you. When students start to learn programming, they tend to think that going from the start of your learning path up to the end of your learning path, which is when you are job ready. So students think that this is a linear path that goes like this. However, this is not really the case. The actual curve to gain skills to become job ready is a bit different. It actually goes like this. Up to here, then it goes down, and then it goes up again. So why is this? Well, I'll explain you why in this video. So this is the beginner's phase, and the curve going up indicates your confidence. So you feel very confident when you're learning the basics of a programming language. So let's say in this course, this would reflect to the first app where I explain you the basics of Python. So in that app, I'm sure that you're feeling very confident. The problem is after you learn the basics and you start to build something. So after you learn the basics, we're here, and then you start to build apps and you realize that you don't feel as confident as you thought you would, because building something is different from the theoretical skills. Now, in this course though, this part is very practical, so this curve will not be that down, but it will be a bit more like this. So it depends on the course, and for some online courses which don't have any building, any practical knowledge, then this graph could be somewhere here. So we're here currently. Once you have learned the basics of Python, then in the course we have about 20 apps that you built together with me, plus 10 apps which you built yourself. So I would say that in the first 5 apps that we built and that you also built, more or less, you'll feel like your confidence is not that high. So you'll feel like your confidence is going down and you're not so motivated. So that's very normal. That's why I'm telling you this, so that you know beforehand not to get unmotivated later on. However, after you build a few apps, you struggle with them, and then after you build some of them, then you'll start to gain your confidence again. So in the next, let's say 15 apps that we build together, plus the apps you'll build yourself, you'll start to gain confidence until you are job ready, because you have built many apps on your own, so you're ready, you know how to do it, and you can get a job as a Python programmer. So this is a graph I wanted you to know how the learning path goes, and I hope this helps you, and see you later.